This video is for you to review integer rules when you are adding, subtracting, multiplying, and or dividing. This is our lesson outline. First, we are going to go over adding and subtracting integers, and then we're going to go over multiplying and dividing integers and the strategies that we have used before in the past to help us, the rules. So in the past, we learned 3 different strategies. Okay, we learned how to find the value of an integer problem using a number line. For example, if it was like 4 minus 6, we had a number line. This was 4. All right, we started at 0. We went to 4, the first number, and then from 4 we minus 6, so we did 6 jumps this way, and in that way we landed at -2, so that equals -2. So we started off this year solving integer problems using the number line. Then we looked at a jar. So if I had 4 minus 6, we did a jar and we said, okay, this represents 4 positive, so 1, 2, 3, 4. And then we said, oh, this represents 6 negative, so 1, 2, 3, 4, 5, 6. And this right here cancels because it's a zero-sum pair. So it makes 0, like when you add them up it equals 0. A positive 1 and a negative 1 cancel out to make 0, so it's called a zero pair. Or some people say zero-sum. Alright, that's the correct terminology for it. We did not use those terms when we were learning it this year, but that's okay. You're learning it now. Alright, so cancel, cancel, cancel. We're left with 2 negatives, so our answer is -2. And then we went over rules, and we used the integer song. Alright, and you guys loved singing that song. We're going to be using that song today. Alright, for as we are reviewing how to add and subtract integers. So here's a song in case you forgot. Alright, so it goes same sign, add and keep, different sign, subtract. Keep the sign of the farther number or use a jar instead. Alright, so keep in mind this represents one part of the song. These two in blue represent a separate part. So if the signs are the same, so if it's -2 minus 3, same sign, add and keep. So add those two numbers because it's the same sign. They're both negative. So 2 plus 3 is 5. So I'm going to put 5. It says and keep. So keep that sign that's negative. All right. And if you think of the number line, you're at -2. From -2, you minus 3 this way. So 3 jumps, you land at -5 right here. Okay. And then for the different sign subtract, if you had different signs, like say it were 2 minus 3, you different sign subtract. They're different signs. This is a positive and this is a negative. You keep the sign of the further number. So which number is further away from 0? +2 or -3? -3. All right, if you look at the absolute value of each of them, this makes 2, this makes 3. This one's further away. It's 3 jumps away while this one's 2 jumps away from 0. So you subtract them. So 3 minus 2 is 1. So I'm going to put 1, but take the sign of the further number. The further number was 3. The sign of it in the problem is negative, so -1. Okay. So you need to remember this song to help you with the problems. So to just reiterate this, I have another slide that will help us. Alright, so integer song dissection. So we have a problem over here where it's the same sign, and a problem over here where they're different signs. So we're just going to look at it again, what I just explained to you on the last slide, but with different numbers, just for clarification. So I have -5, -8. All right, so don't worry that this one is shorter than that one. It's just the way that it came out when we were typing it on the computer, so it doesn't matter. Okay, so it says same sign, add and keep. It means if the integers have the same sign, which they do, negative, negative, add the two numbers and keep the sign. So 5 plus 8, that's 13, and keep the sign. Okay, both integers are negative, so I can add the numbers. 8 plus 3 equals 13. All right, oops, I'm sorry, I did not mean to put that negative. You add, so both integers are negative, so you can add the numbers. 5 plus 8 equals 13. Since the sign of the integers that was the same or negative, so the integers that are the same or negative, we can keep it negative. So then it makes negative 13. And if you were to use a jar to verify, 5 negatives for negative 5, and then 8 negatives, 1, 2, 3, 4, 5, 6, 7, 8. If you add them up, then you get 13. So that makes negative 13. Now if we look over here for this one, it says different signs subtract. So I have different signs. This is a negative and this is a positive. It means that if the integers have different signs, which they do, subtract the numbers. So 8 minus 5. Just look at the numbers individually. So 8 minus 5, that's 3. But you gotta take the sign of the further number. So which number is further away from 0? Negative 8 or 5? It's negative 8 because that's 8 jumps away, while this one's 5 jumps away from 0. So then the answer is negative 3. Okay, that's what everything right here is saying. Right, the integers have different signs. One is negative while the other is positive. So you got to subtract the numbers. The furthest number from 0 is negative 8. So that's the sign of the solution. So it will be negative 3. And if you want to use the jar, so 8 negatives and 5 positives, cancel, 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 cancel. There's my negative 3 right there. Okay, so it works. So keep in mind that the rules that that you are using, use them for all of the integer problems, but mainly the larger numbers. If you're trying to use a jar, the jar is meant for smaller numbers, so feel free to use a jar to check your work for smaller integers, like the ones that we just saw right here. These are smaller integers, all right? But you're not going to want to do a problem that's like negative 86 plus 108 for a jar. You're not going to want to make a jar and put 86 negatives and then 108 positives. There's no way. That's way too time consuming. Who wants to do that? So that's why there are rules, the song, to help you out. All right, the last two slides, the last two paper slides I showed you connected the two, the rules with the jar, to prove that the rules do work. All right. So do not use a number line or a jar for large numbers. Use the rules. So let's do this as an example right here. So we have a couple examples. So we have negative 40 plus 24. Are they the same sign? Ask yourself, are they the same sign or different? And then ask yourself, are we going to add or subtract due to that? So are these the same or are they different? They're different. One is negative, one is positive. So if they're different, are we going to add or subtract? Well, then that is where you start thinking of the song. Same sign, add and keep, different sign, subtract. So I'm going to subtract in this case. So 40 minus 24. Okay. All right, so 16. All right, now different sign, subtract. Remember, the subtraction has another part. That's why it's in blue. If you look back at the song. All right, this part, different sign, subtract, keep the sign of the further number. Those Those two lines are in the same color because they go together. So you don't just subtract, you also got to take the sign of the further number if you're subtracting. The further number away from 0 is negative 40, so your answer is negative 16. Okay, so this makes negative 16. Let's look at this one. Example 2. Are they the same sign or are they different? They're different, so what are we going to do? Subtract. All right, remember when you subtract, you have to do two things. You subtract the numbers, then you take the sign of the further number. Which one's further away from 0? Negative 80 or 10? 10 jumps away from 0 or 80 jumps away from 0? 80 is further away. So your answer is negative 70. Let's look at example 3. Remember, you got to ask yourself these. Are they the same sign or are they different? So are you going to add or subtract? Okay. Same sign or different? Same sign. So we're going to add them because if they're the same sign, you add. Same sign, add and keep. So 34 plus 30, that's 4 and 6. Add and keep. For when you're adding, there's kind of like a second part because it's not just add and keep. So keep the sign that was already there, negative 64. Okay, and think about if you had a jar, you had 34 negatives and 30 negatives, pretend those are negatives, nothing cancels. The only thing that can cancel with the negative is a positive, and there are no positives, so you're going to just have to add them all up. Let's look at this one. Negative 16 plus 8. Are they the same sign or are they different? Different. So what are you going to do? Subtract. So 16 minus 8, right? That's 8. Now is that going to be positive or negative? 8. Well, after we subtract, we got to take the sign of the further number. The further number here is negative, so negative 16, so the answer is negative 8. Okay. So go ahead and practice these two. Press pause and then come back. Go ahead. Okay, so remember, ask yourself, are they the same sign or different? So are you going to add or subtract? So we have 73 minus 90. Those are different signs. So you should subtract 90 minus 73. All right, and take the sign of the further number. The further number is negative 90, so your answer is negative 17. For this one, they're different signs, so subtract. All right, and keep in mind, I'm only subtracting these numbers. I'm not even thinking about positives or negatives at this point. I'm just subtracting the numbers. All right, then I take the sign of the number that's further away. In this case, it's negative 45. So our answer is negative 22. And the number that's further away will not always be negative. It just seems like that's happening right now, but that will not always be the case. So go ahead and pause this after I'm done talking and try these 4 problems on your own to make sure that you understand what you are doing. Okay, go ahead. All right, so these numbers are different, so I'm going to subtract. The signs are different. So I'm going to get 31, but take the sign of the further number, negative, so negative 31. This one, the signs are the same, so I'm going to add them. And when I do that, I get 112, but I'm going to add and keep. So the answer is negative 112. Number 3, these are different signs, so I'm going to subtract. All right, take the sign of the number that's further away from 0. Positive 76 is further away, so my answer is positive 31. You can say positive 31 like that with the symbol, or just say 31. Because if you don't see the sign, it's implied that it's positive. All right, for this one, these are different signs, so I'm going to subtract. Take the sign of the further number, negative, so equals negative 14. All right, next slide. All right, we just finished reviewing adding and subtracting integers. Now we are going to go ahead and review multiplying and dividing integers. Okay, hold on. My cat is having a heart attack outside the door. Hold on. Okay, I'm back. Okay, so multiplying and dividing integer rules. So when you're multiplying and dividing integer rules, there are two things that I like to do. First, I multiply or divide whatever numbers that they have. If it's asking me to multiply, I multiply. If it's asking me to divide, I divide. I just look at the numbers. I do not look at the signs first. Then after I do the actual math by looking at the numbers, then I look at the signs. Okay. These are the rules for when you are multiplying or dividing integers. If they're the same signs, your answer will be positive. If they're different signs, your answers are going to be negative. For example, if I have 5 times 2, I know that's 10. And remember, if I don't see a sign in front, it's implied that it's positive 10. Okay, that makes sense. So if I do negative 5 times negative 2, 5 times 2 is 10. I just did the math using the numbers, multiply or divide numbers. Then look at the signs. If they're the same sign, which they are, a negative and a negative, then my answer is going to be positive 10. Now let's look at the different signs. If they're different signs, my answer will always be negative. So if I have negative 3 times negative 3 times 2, that makes negative 6. 3 times 2 is 6. A negative times a positive is a negative. So if they're different signs, your answer will always be negative. If they're the same signs, your answer will always be positive. And this is for multiplying or dividing integers. All right, for adding and subtracting, use the song. Some helpful methods that we did before to help you remember the signs, that if they're the same signs, you're going to make it positive, and different signs, you're going to make it negative. We did tic-tac-toe. So what we did was we wrote positives diagonally, and then the rest were negatives. And we can use this by saying a negative times a negative is a positive. A negative times a positive is a negative. A positive times a negative is a negative. Now this does not only apply for multiplying, it also applies for dividing. Look, a negative divided by a negative is a positive. A negative divided by a positive is a negative. Because look, same signs, positive. Different signs, negative. Different signs, negative. And you don't have to read this from left to right. You can go from top to bottom, right to left, bottom to top. It's up to you. Because look, same signs, positive. Different signs, negative. Different signs, negative. And if you go diagonally for this one case, same signs, positive. Or same signs, positive. Okay, so that's one strategy, one method we used, a good visual, and another one was the pizza face. All right, so if you draw this very tiny on your paper with your pencil, you can use your fingers to move, to cover some of those signs up. So if they're the same sign, cover up the two signs that are the same, your answer is positive. If they're different, cover up two that are negative, negative. If you cover up these ones that are different, your answer is still negative. Okay, so that's the pizza face. So feel free to use any of these methods and strategies. So go ahead and pause this after I'm done talking and try those ones out to make sure you understand. So multiply the numbers first and then look at the signs. So go ahead and pause and try it. Okay, so 4 times 9 is 36, and they're the same signs, so positive 36. So same signs, that will get me a positive. If they're different signs, that will get me a negative. And remember, I can use my tic-tac-toe. Okay, over here, 2 times 8 is 16. Different signs, so here are different signs, so I'm going to have a negative as my answer. There we go. 10 times 5 is 50. Same signs. Look for somewhere that says same sign. Same sign. Negative, negative, so it's going to be positive, so positive 50. Over here, different, oh, I'm going to multiply first, so 12 times 5. All right, you should know this, but in case you could do it on the side. 5 times 2 is 10, 5, 6, so 60. All right, a positive 10 is a negative. Those are different signs, negative. Look, different signs, negative. So negative 60 is your answer for that one. This one, 8 times 5 is 40. A negative times a negative times a negative is a positive. It says right here, same sign, positive. Right here, 3 times 4 is 12. A negative times a negative is a positive, so positive 12. Now go ahead and practice these ones for dividing, and then come back. Press pause and then come back. Alright, so remember, I can use same signs. That makes a positive answer for multiplying and dividing. Different signs make a negative answer. Okay, and I can use my visual, this one, or pizza face. On the last one for multiplying, I could have also used pizza face. It's up to you. Alright, so first look at the numbers, then look at the signs. You can look at the signs first if you want and then do the number. It doesn't matter. If you do the signs first, then more than likely you won't forget to do the sign, so it might be better to get in the habit of doing the sign first and then do the number. Okay, so, but it's up to you. 15 divided by 3 is 5. A negative divided by a positive. So if I look at my pizza face, cover up the two different signs, I get a negative. So negative 5. 20 divided by 4 is 5. Same sign, positive. 40 divided by 8 is 5. Different signs, negative. 45 divided by 9 is 5. All right, a negative divided by negative is a positive. There we go. 8 divided by 12. Whoa, I can't divide 12 into 8 evenly. Over here I could divide 9 into 45 evenly, but I can't for this one, so I'm just gonna have to simplify. So I might want to, I have a sign right here, so let me look at the sign. A positive divided by negative is a negative, so I know in the end my answer is going to be negative something. So let's find a common factor between these, and that's 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So there we go. Negative 2/3. Over here, a negative divided by a negative is a positive. And then, well, 24 cannot go into 12 evenly, so I'm going to have to find a common factor, which is 12 in this case. So it's going to be positive 1 over 2. So positive 1/2. Okay. These two were kind of tricky because they were fractions, but you should know how to do fractions. So along with those last two examples, let's talk about these signs. Okay. So integer fractions, right? When you have fractions, multiply across and simplify. So if I have 4 times 4, that's 8. A negative times a negative is a positive. 5 times 3 is 15. We're done. You can say that a positive divided by positive is still positive, so that still makes the whole fraction positive. Let's look at this one. 2 times 3 is 6. A negative times a negative is a positive. 8 times 6, right? That's 48, but it's going to be a negative. Oh, but I got to simplify. But let's look. A positive divided by a negative is going to be a negative. Okay, so a negative. And then I need to divide. Let's try by, let's do it by 6, because 6 is the GCF, the greatest common factor. So it'll be 1 over 8, right? But where do I put this negative? Do I put it on top or on the bottom? Well, that's why I have this slide. Okay, it doesn't matter if the negative is in the numerator, the denominator, or in front of the fraction. It still means the fraction is negative. For example, if you have it on top, a negative divided by a positive is still a negative. It still means the whole fraction is negative. It doesn't matter if it's on the bottom, because look, a positive divided by a negative is still a negative. It still makes the whole fraction negative. So it does not matter if the negative is in the numerator, denominator, or in the front. Okay, still, both of these still mean this. It means the whole thing is negative. So over here, if I have a negative divided by a negative, it equals a positive. And it doesn't matter if I write positive up here, positive down there, positive in front, or if I just leave it alone, like how this one was, and just write 4 over 5. It's the same thing. So go ahead and practice these ones. This is just an extra slide for practice. Press pause and then come back. Alright, so this one should have been negative 18. This one should have been positive 2. This one should have been negative 1/5. And that could have been written in front, on top, or on bottom. It does not matter. Okay, so just pick one. Over here, this would have been negative 4 over negative 25, which just equals 4 over 25. Okay, a negative divided by a negative is a positive. All right, over here, just go in order. 4 times 3 is 12, times 2 is 24. Okay, but a negative times a negative is a positive times a negative is a negative. There we go. But what about these kinds of problems where I have two signs in the middle? What do we do with those? Before, they've been, let's see, like for example here, there's a sign in front of, one sign in front of each of the numbers. One sign, not two signs in the middle. This one has two signs. Well, there are different ways you can think about it, but if you think back in 6th grade math, this notation right here, the negative and then in the parentheses represents opposite. So it's saying what is the opposite of whatever is inside? The opposite of whatever is inside, the opposite of negative 4 is positive 4. Okay, so you can say, oh, negative 4 for this negative 4. What's the opposite of positive 5? Negative 5. And then you do, you can think of the integer song, negative 9. Okay, same sign, add and keep. But you can think of it that way, or think about this. If I have negative 4, I'll use this example. I have negative 4 plus negative 5. Well, think of this as multiplication. What's a positive times a negative? A negative. So negative 4 minus 5, still negative 9. Over here, a negative times a positive is a negative. Okay, and I get 4 minus 5, which is negative 1. This was a positive 4. This one was a negative. That one was also a negative. Let's look over here. Okay, the opposite of a negative is a positive, but if I multiply these, a negative times a negative, that makes a positive. So I get 4 plus 5, which equals 9. Okay. So the same rules still apply. You can think of the opposite from 6th grade math, or think of, okay, that's multiplication, it's parentheses. So what's a positive times a negative? Negative. What's a negative times a negative? Positive. So the integer song, right? If you didn't notice, you can also use the integer song to help you with multiplying and dividing too. You just have to think about it in a different way for it to work. For example, same signs add for when you're adding integers, but instead when you're multiplying, you can think same signs mean positive. Okay, positive, not add. Different signs subtract, not subtract if you're trying to apply the song to multiplying and division. Think negative. Okay, think negative. And then you can also apply it to this one. Different signs add. So it'll be 4 plus 5. Oh, sorry, same sign add. Same, so over here think of it as same sign add. So 4 plus 5. Different signs negative, so 4 minus 5, which makes -1, and that makes 9. Alright, so that is your review for integers. Hopefully it helps you out so that you can finish the rest of that lesson if you are running into trouble. Alright, bye. Thank you to the interpreters who are helping interpret this video. Thank you.